Here we go. So I have 3 over 5 plus 1 over 6 minus 13 over 15. So I'd like you to look at my denominators of 5, 6, and 15. And I'd like you to tell me what my LCD is. What is my LCD of 5, 6, and 15?
30.
It is 30. Okay, and that is absolutely correct. Your LCD is 30. So what we're going to do now is we are going to look at how we got 30. We're going to look at what our brain was doing when we determined that 30 was our LCD. So what I'm going to do is I am going to rewrite each one of these denominators in primes. I am going to factor them down to primes. So that means I am going to break it down as far as I can break it down. So what does 6 break down to? What times what equals 6? 3 times 2. Okay? 3 times 2 are both prime numbers. That means they can't be broken down anymore. So I have factored 6 into primes. 5 can't be broken down at all. 5 is a prime. Okay? Now, what does 15 break down to? 5 times 3. Okay. Now, 30 is 5 times 3 times 2. That's how you break 30 down. So, what we're looking at, when I'm looking at my LCD, I have to make sure that each one of these LCDs is covered in my least common denominator for all 3. So do you see how I've got a factor of 5 right here? And here I also have a 5. Okay? Do you see how I have a 3 here? And I have a 3 right there? I have a 2 here, and I have a 2 right here. Now, this 5, I don't have to write this 5 down again because I already have it. I just have to make sure that 5 is accounted for. I don't have to write it down again. This 3 is already accounted for, so I don't have to write it down again. That is how I'm getting my LCD. And I know that we're looking at it a little bit differently, but we're doing that because we're about to have to break down rational expressions, and that is going to be fractions with variables, and we're going to have variables in the denominator. So if we think about it this way, it's going to be helpful. So what I'm going to do now is I've got 3 over 5 plus 1 over 3 times 2 minus 13 over 5 times 3. So what I want to do now is I am going to write in the denominator and the numerator whichever of these factors right here are not in each one of my denominators. So my first denominator has a 5 in it. That's the only thing that's in that first denominator. So of these right here, what is that missing?
32.
3 and the 2. So I've got to multiply my denominator times 3 and times 2. If I multiply the denominator times that, what do I have to do to the numerator?
The same thing.
Same thing. So here I'm going to multiply times 3 times 2. For my second fraction, I have 3 and 2 in the denominator already. What am I missing? The 5. So I'm going to multiply my denominator times 5 and my numerator times 5. Okay? Now for my third one, I already have a 5 and a 3. What am I missing? So I'm going to multiply my denominator times 2 and my numerator times 2. Okay? The different colors are helpful. And this is being recorded, so you can go back and listen to it at any time. So now I have my denominator. And now I can add and subtract what I need to on top. 3 times 3 times 2, what is that? Good. What is 1 times 5? Okay. Now, this is minus. So I am subtracting 13 times 2, which is 26. So don't lose that minus sign there. 18 plus 5 is 23. Minus 26 is minus 3. And that is over 30. Can negative 3 over 30 be simplified again? Yes. So negative 1 over 10 is my final answer. Right there. Okay? So now we're going to throw a variable in there. Can I move to the next screen? Okay. I have a minus 2 over 2 minus a minus 6 over 6. So what I want to do is I want to break that numerator down. I want to break the numerator down. Or denominator, I'm sorry. I'm going to break the denominator down. So I have a minus 2 over 2, because 2 is prime, minus a minus 6. How do I break 6 down? How do I break 6 down? 2 times 3. Good. Okay. So now my LCD has got to make sure that everything down here is covered. So I'm going to write down a 2. Okay. So this is covered. This 2 right here is already covered because I wrote down a 2. What else do I need to write down for this denominator? What's missing? The 3. Okay? So for your LCD, you've got to make sure all of those prime factors are included. And this is going to help you when we bring variables into our denominator. So I'm going to rewrite this. I have a minus 2 over 2. I am going to change this minus to a plus, and I'm going to make it in the denominator, or numerator. When I do that, I have to put a minus 2 in parentheses. I have to, because that negative belongs to everything in the numerator. Okay? Then I have 2 times 3. In my first fraction, what am I missing in the denominator? I've got a 2, so what do I need to add to that? Good. So I'm going to have 2 times 3. I am multiplying that 3 times that entire binomial. So I'm going to have to divide that, distribute that. I'm going to have to distribute that. Now, is there anything missing in my second one? I've got 2 times 3 in my second one. I have 2 times 3 as my LCD. Do I have that one covered? Yes. Okay. So it's 2 times 3. I've got to distribute this 3. Even though it's at the other side, I've still got to distribute it. So I have 3a minus 6 minus a plus 6. Okay? That minus sign. So I took this minus sign right here and I moved it to the numerator. I have to distribute that. So that's how I get my minus a plus 6, because it's a negative times a negative. So sometimes that distribution right here is where students get confused. Now, 6 and negative 6 cancel. So I am left with 3a. No, I'm not left with 3a. What am I left with? 3a minus a. 2a. So I have 2a over 2 times 3. Okay, I'm going to rewrite that. I'm going to write this up here so we can all see. 2a over 2 times 3. Now, I didn't multiply my denominator out for this exact reason. So I could look at this to see if anything needed to be simplified out. What can I simplify? What's on the top and the bottom? 2. Okay? So my 2, and so my final answer here is a over 3. Okay. Are we ready to look at this with variables?
And as you veto this and go home.
No. I guess maybe I shouldn't ask that question if I... Yes, sir?
When we're factoring into primes, does it matter what order we put
No.
the two factors in?
It doesn't.
Doesn't have to be localized?
That's a good question. The question is, when we're factoring in primes, does it matter what order we put those numbers in? So instead of writing 2 times 3, could I write 3 times 2? The answer to that is yes. Now, some of us have OCD and we like to put it in order, and that's completely fine, but it does not matter. Good question. Okay, let's do the next one. So now, we are using that same principle. We are using that same principle here. So here we have 3 over 2x plus 5 over 3y. So my first step would be to break down those numbers in the denominator if I can. Okay, these happen to both be prime. So 2 doesn't break down and 3 doesn't break down. So my LCD has to have a 2 and it has to have a 3. They've got to be covered. So I've got a 2 and I've got a 3. But now I've got to accommodate for the x and the y also. So I'm going to have an x and I'm going to have a y. So when I write 3 over 2x plus 5 over 3y, I go back. For this one, I've got a 2 and an x, so that's covered and that's covered. What am I missing? 3 and the y. So I've got to multiply the denominator 3 times y. If I multiply the denominator times that, what do I do in the numerator? Okay. Now, for my second rational, I have a 3 and I have a y. So this 3 and this y is covered. What am I missing? Okay, I'm missing a 2 and I'm missing an x. So I have to put 2 times x. If I multiply the bottom, 2 times x, I multiply the top, 2 times x. Okay. 3 times 3 times y is 9y. 5 times 2 times x is 10x. I'm still going to write the bottom factored out. Okay? And I do that Just like here, I was able to cancel a 2. Okay? I kept it factored out because I very clearly can see that these 2 cancels. Okay? Here, I've got to ask myself, is there a GCF in 9y plus 10x? Is there a GCF in 9y plus 10x? No, there's not. Because there's nothing I can factor out, I'm done. If you wanted to go and say 9y plus 10x over 6xy, you can. Now, I want to make it very, very clear. This y and this y cannot cancel. This x and this x cannot cancel. The reason for that is because the 9y and the 10x are being added together. They have to stay together as a unit. That binomial cannot be separated unless you have a GCF that can come out of both, or you have that exact binomial in the denominator. That's the only time that can be simplified out. Okay? Okay. Let's move to the next one. So we've got a couple of different things going on here. We have 12 that can be broken down to primes. We have 15 that can be broken down. And we also have a subtraction sign. I move that subtraction sign to the numerator as early as I can. So instead of thinking 7 over 12ab minus 11 over 15a squared, I think of it as 7 over 12ab plus negative 11 over 15a squared. That is going to be helpful for you to think about it that way. So, I'm going to rewrite it. Okay? Now, 12, you are probably thinking that 12 breaks down to 3 times 4. 3 times 4 is 12, but can 4 be broken down further? Yes. Okay, so 12 is 3 times 4, but 4 is 2 times 2. So 12 is 3 times 2 times 2. And that's going to be important because we've got to account for both of those 2's. Then I have times A times B. This is plus negative 11. What does 15 break down to? Good. 3 times 5, and then I have A times A. Now, when we are pulling out a GCF, one of the things that I told you is that you always look at the lowest exponent when you're pulling out a GCF. So when I'm factoring and I pull out a GCF from a polynomial, I am looking for the lowest exponent. So if I've got x to the third, x to the fourth, and x squared, I can pull out an x squared because that's my lowest exponent. The opposite is true with LCD. With a least common denominator, you are looking for your highest exponent. Your highest exponent has to be in your LCD. So on this one right here, I have an A and I have an A squared. What has to be part of my LCD? A squared. Yes. A squared has to be part of my LCD. Okay? So, we're going to deal with my numbers. I have a 3 here. So I'm going to write down a 3. I've got to account for both of those. Think of it as 2 squared. because both of those 2's show up in the same denominator, I've got to write them both down. Okay? Then I have an A, and then I have a B. Now, I've already got my 3. I do not have my 5, so I have to account for that 5. So I'm going to do times 5. One of my A's is accounted for right there. But I've got another one. So I've got to make this A squared as part of my LCD. So my LCD is going to be 3 times 2 times 2 times 5 times A squared B. Okay? 3 times 2 times 2 times 5 times A squared B. Everything that's in each of the denominators has got to be accounted for in my LCD. Now, 3 times 2 times 2 times 5 is 60. Does 12 go into 60 and 15 go into 60? Yes. Yes, ma'am.
You have 3 A's when you have A squared.
Say that again.
Like you have 3 A's, but we have A squared.
Excellent. Excellent. Excellent seeing that. Okay? What is the highest exponent I have in either one of the denominators?
A squared.
A squared. So that's what I have to worry about. You are correct that I have an A in one denominator and A squared in the other denominator. Do you see how I have a 3 in the first denominator and I have a 3 in the second denominator? How many 3's did I write in my LCD? Just 1. The same is true for the A's. I have to identify the highest exponent. That is an excellent insight that you had. And so when you make that connection, you're going to be good. So good job.
I have a question. Why didn't you just do 6 times 2?
Why didn't I do 6 times 2 for 12? You want to break it down as far as you can go. Okay? So 6 times 2, the 6 can be broken down to 2 times 3. And the reason for that is if I had 6 times 2 over here and I had 3 over here, I might have written down a 3 and a 6. And I didn't need that second 3. I only needed the 3 one time. Okay? Okay. So now we're going to figure out what we're missing. So I have 7, 3 times 2 times 2 times A times B, plus negative 11, 3 times 5 times A times A. So I have a 3, I have 2 2's, I have 1 A, and I have a B. I am missing a 5, and what else am I missing? An A. Excellent. Okay? So if I multiply the denominator times 5 and times an A, I have to multiply the numerator times that also. Now I'm going to look at my second one. I have a 3, I have a 5, and I have an A squared. What am I missing? What am I missing in my second one?
I'm not seeing any B's in the second one.
2's. I'm missing both 2's. And I'm missing a B. If I multiply the denominator times it, I've got to multiply the numerator. Okay. Now, 7 times 5 times A is 35. A. Negative 11 times 2 times 2 times B is negative 44B. Okay? At this point, I ask myself, is there something common? Is there a GCF in 35A minus 44B? Is there anything common to both? A 2, a 3, a 5, a variable? No. So then I'm going to multiply my denominator. 3 times 5 times 2 times 2 is 60. And I'm left with A squared B. And this is my final answer. That's my final answer right there. Now, these A's cannot cancel because of this minus. This 35A minus 44B is a unit. It is a binomial. It has to stay together. The only way you can cancel that is if you have the exact same thing in the denominator. These cannot cancel for the same reason. Okay? So this is your final answer right there. Okay? I actually think this type of problem right here is more difficult than when we have binomials and trinomials as the denominator. I think this is kind of the worst part. Our next problem is going to have a binomial and a monomial as a denominator. Can I move from this screen? Can I move? Okay. So here, I've got an x minus 3. That is a binomial, and it has to function together. That x minus 3 cannot be separated. Then in my second fraction, I have an x. So my LCD is going to be x minus 3 times what? What's in the second fraction? An x. That's my LCD right there. Okay, I've got to account for both. And x minus 3 are two different factors. The x minus 3 is a binomial that has to stay together. Okay, so now I have x over x minus 3 plus 4 over x. What is missing in the first one?
In the first one, you're fine.
I'm not fine. X minus 3 and x are two different factors. So what do I have to put there? X. Okay, so I have to have this x right here. What am I missing in the second one? Good. I think that's a little bit easier to see than all those extra variables on the last one. Okay, you may disagree with me, and that's fine. I just think it's a little bit easier to see.
I wrote this, I worked a little bit ahead and wrote this right, but still thought it wrong when we got to it.
I gotcha. Okay, so now my denominator is x times x minus 3. X times x is x squared. I've got to distribute that 4. So I get 4x minus 12. Okay? I tend not to multiply that denominator out, and you're fine not multiplying that denominator out. You might want to check the numerator. This is a correct answer, but another correct answer is x plus 6, x minus 2, okay? That lets you see if there's a factor in the numerator that can simplify with a factor in the denominator. It can't, but if you left it as this, you would be okay, or if you left it as this, you would be okay.
One's just an even more factored out version of the others. Right?
Correct. Correct. Either is fine. Okay. One more, and then we're going to do a division problem before we go. Okay? Here I have 2x over x plus 1 minus 3. What's the 3 over?
1.
Yes, it is over 1.
Yeah, Mark.
Okay. My LCD is x plus 1. Now, I am going to go ahead and move my subtraction sign to the numerator. Okay? So I changed my subtraction to addition, and I made my numerator negative. Is there anything missing from my first rational expression? Is there anything that I need to do to the denominator? No, I don't. My second one needs the x plus 1. And if I multiply the bottom times x plus 1, I have to multiply the top times x plus 1. X plus 1 is my denominator. 2x, this negative 3 has to be distributed. So I have minus 3x minus 3. So I'm left with negative 1x minus 3 over x plus 1. You may also have negative x minus 3 over x plus 1. And again, those are binomials, and binomials stay together. You can't separate them and start canceling things. So this is your final answer right here. Okay. Can I move from this screen? Because I'm going to go back a bunch of screens. Okay. This is division. Now, we talked about multiplication. We talked about simplifying. So I want to do a division problem for you. Students tend to do okay with simplifying, multiplying, and dividing. They struggle a little bit more with the addition and subtraction. So practice that addition and subtraction before we come back on Wednesday. Practice it.
I see that.
Okay?
Squares situation going on in one of these fractions.
Good. Okay, and I'm going to let you do that. So what we do here, when we are dividing fractions or dividing rationals, we keep my original rational expression. I change my division to multiplication, and I flip my second rational expression. Okay? What I am doing, the mathematical term for this, is I am multiplying by its inverse. That's what division is. I multiply by its inverse. The KCF allows you to remember it a little bit easier. Okay? You need to take the time and rewrite this. Do not try to do these things in your head. Take the time to rewrite them. So I have 3a squared plus 12 over 3a squared minus 15a. I change my division to multiplication. Then I flip. I'm doing the reciprocal. So my denominator becomes my numerator. My numerator becomes my denominator. Okay, now you have got to factor all of this. And hopefully we are comfortable factoring. You've got to factor this. I am going to give you 3 minutes to factor these. Now, the a to the 4th minus 16 is the more difficult one to factor. So I'm going to do that off to the side, but you should be able to factor it. But I am going to do it off to the side so you can see it. So factor every one of these, please. factor. And so we definitely need to talk and get some practice on that. This one is a little bit more challenging because it's a to the fourth. We need to remember that a to the fourth is a perfect square. And sometimes we forget that. A to the fourth is a squared times a squared. We've got minus 16, so this is a difference of perfect squared. It becomes a squared plus 4 and a squared minus 4. The a squared plus 4 cannot be factored further. Okay, so we keep it a squared plus 4. The a squared minus 4 is the difference of perfect squared again, and we've got a plus 2 and a minus 2. So that's how I got this one right here. My top left one, I can factor out a 3. The first time I did this problem, on the 3a squared plus 12, I factored out a 3a, and I was wrong. I had to go back and fix it. So just be careful. Look at those. Make sure you're looking at it correctly, because I made a mistake with that. Okay? So the first one factors to 3a squared plus 4. Underneath that, I can take a 3a out. And I'm left with 3a times a minus 5. A squared minus 3a minus 10 is your pretty straightforward trinomial. Your product is negative 10. Your sum is negative 3. So that factors to a minus 5 and a plus 2. We are multiplying, so it is a cross-cancel situation. If it's on the top and if it's on the bottom, you can simplify it out. Now, here I've got a 3 that I can simplify. Be careful with that a right there. It's easy to lose that a, so be careful. Okay, that's why sometimes the different colors are helpful. I have a squared plus 4, a squared plus 4, a minus 5, a minus 5, a plus 2, a plus 2. In the numerator, everything simplifies out. What am I left with?
Just be a times a minus 2.
That's in the denominator. Okay, so I do have a times a minus 2 in the denominator. 1. Okay, I have divided everything out, and I am left with 1. When everything in the numerator or everything in the denominator cancels out, you are left with 1. You are not left with 0. Okay? So look at the 3 right here. Okay? This 3. What I said was 3 goes into 3 how many times? How many times? 1. That's where the 1 comes from. And that's what I'm saying on every one of these. I am dividing a squared plus 4 by a squared plus 4. When I divide something by itself, what do I get? 1. Okay? So this is my final answer. Okay? So, on Monday, when there's no class, I want you working on this homework. On Wednesday, we're doing a class activity, and you have a quiz on Friday. Okay? Several of you came in late.